Hello, and welcome to Lesson 1-4 in Math 1025. Lesson 1-4 is titled Avoiding an Empty Wallet, and you're going to be learning about using exponents in order of operations. This is one of the stranger sections because the classwork is listed after the group work. That's okay, we're still going to do the classwork and you'll do your group work during class time. I'm actually starting on the top of page 50, a little bit above where the classwork starts. Just to make sure we understand these a little bit, you'll get into more detail in your group work. They'll do some more definitions and things, but account 1 in your group work is going to be dealing with simple interest. Simple interest is known as linear growth. And linear growth is found by adding the same constant number each time. It could be each year, it could be each month, depends on how you're earning the interest. In account 2, we're dealing with compound interest. Compound interest grows faster because you're multiplying by the growth factor. You're earning interest on your interest, and you find it by multiplying by the same growth factor. The names also are indicative of what you're going to be looking at. Linear does mean a line. Exponential would actually be a curve. Most things in the real world are compound interest. It's definitely the way you want to invest money because you earn money, you earn interest on your interest, which is very valuable. So in the classwork, they're going to talk a little bit about what you will see in the group work. Account 2 is repeated multiplication. So that's our compound interest. It's repeated multiplication, and a shortcut way we have of writing repeated multiplication is by using an exponent. So we can use an exponent to shortcut it. And then they give us what the formula would look like for compound interest. If we invested $1,000 at 5% interest for 7 years, this is what the formula will look like. The 5% is part of your growth factor. So 1.05 is your growth factor. The 7 is the number of years we're investing for, and the 1,000 is your initial deposit. In number 2, they ask us to write it out without using a calculator. We'll get to the calculator in a minute. So we're going to start with $1,000, and we're going to multiply it by 1.05, and we're going to repeat that 1.05. How many times do you think I need to repeat it? Should be 7, because that's the number of years we have. So I'm going to write that 1.05 7 times. It's 2, 3, 4, 5, 6, and 7. And you can see why this might get tedious, especially if we were investing for 20 years or 30 years. This may be absolutely tedious. We can throw this into the calculator exactly as we wrote it out there. So your calculator, if you have a Texas Instruments, should look something like this. And I'm going to type in what we just did. So we did 1,000 times 1.05. Sometimes the on-screen calculator is a little laggy, and today it apparently is. Times 1.05. We're going to do that 7 times, just like we wrote out. And then we're going to talk about a shortcut. That's number 3, number 4, number 5, number 6, and number 7, and then we hit enter. It tells us that we have $1,407, and we'll round to penny because it's money, 10 cents. So our answer is we have $1,407.10 after 7 years. Now that got tedious typing it into the calculator like we did. So what we'd like to do is type in our shortcut that we just talked about in number 1. Number 1 said I can do it as an exponent. So I'm going to type in 1,000 times my growth factor, that's that 1.05, raised. Now on your calculator, to raise something to a power, if you've got the graphing calculator, it's called a caret button. It looks like a triangle missing its bottom. On the TIs, it's below the clear button and above the division button. and then I want to type in the 7 because that's how many years I'm investing for. I got the same answer, and it was a whole lot easier to do it that way. So definitely get some practice with the calculator. It's a great tool. 4 goes back to the simple interest account where we're only going up by $50 each year. They want us to write a calculation that would find the value after 7 years and then calculate that value. So with simple interest, I am starting with my $1,000 investment, and then I'm earning $50 per year. And in this case, we have 7 years. And now we can do it in the calculator to figure out what that answer is. So type in 1,000 plus 50 times 7. And I got 1,350. So already you're starting to see that compound interest is definitely grows faster and is better if you're investing that way. Let's go to the next page, page 51. And now they want us to summarize again what we've learned about linear and exponential growth. So in linear growth, we start with an initial value, and then we're going to do that value plus a constant times however many periods I'm investing for. So it's repeated addition. With exponential growth, we take our initial value and we start out right into multiplying. We are going to multiply as many times as I have years. So we're going to take that growth factor raised to a power. And that power will be however many time periods that you're investing for. All right, so without trying to give away the answer to question 6 too much, part of it involves a power. What is the significance of this power? Well, the power is the number of time periods. In a lot of times that's years, and a lot of the problems we do in here, but it's the number of times that the interest is being calculated. And again, we do a lot of yearly compounding in here, but if you go on to a finance course, you may see quarterly, monthly, daily, continuously. You may see all of those. So again, linear is a straight line. It stays the same every year. Exponential is a curve, and it starts getting really high really fast. And they summarize this very nicely in the purple box. They do give us a solved example here. I love these. These are new to the new edition. They work you through an example with compound and simple interest, and they are showing you the formula. So definitely look through the example. It's very helpful. And it's kind of nice to see the difference between compound and simple. Again, compound is going to earn a lot more money. All right, page 52, number 8. It's asking us to use what we've learned to calculate the value after 20 years in each of the accounts that we've been studying. So we're going to do account 1, which is the simple interest. So I'm going to put a 1 and we'll say simple interest. We just talked about that formula. That formula is going to be the amount we invested, the 1,000, plus the $50 we're earning per year times 20 years. And now I can put that into my calculator. So I can type in 1,000 plus 50 times 20, and I get $2,000. That means after 20 years, my simple interest account will have $2,000 in it. Let's do this next one in a different color. This is going to be our second account. It's compound interest. And we're going to use our compound interest formula. That's where you take the initial amount invested, the $1,000, times the growth factor. Now it was 5% interest, so my growth factor is going to be 1.05. You are keeping 100% of your money that you invested, and then you're gaining an extra 5%. And then we're going to raise that to the 20th power. So I definitely want my calculator for this. I'm going to take 1,000 times the growth factor, that 1.05, into my parentheses and raise it to the power, that's that caret button that's on the right hand side of your calculator, a triangle without a bottom, to the 20th power. And then we hit enter, and it's going to do the work for us. So in my compound interest account, I will have $2,653, and then we're going to round that. The 7 tells the 9 to round up, so it's going to be 2,000, helps if I can see it, $2,653, and when we round correctly, it's going to be 30 cents. All right. Orange boxes are extra examples. You're welcome to do those and ask about them during class. So now we're kind of getting away from interest, and we're going to do a couple more problems that are similar, but just not with interest in investing at this point. It says, in her final 2 days of preparation for a triathlon, Amal hopes to swim, run, and bike a total of 50 miles. She works out at a nearby state park with a swimming quarry and a running biking trail. One lap in the quarry is 0.25 miles, it's a quarter mile. And the trail is 3.3 miles long. The first day, she swims 6 laps, runs the trail twice, and bikes it 5 times. How many more miles does she need to cover the second day? So we know that we're trying to get to that 50. That's my goal. I want to get to a total of 50 miles. So I need to first of all figure out how much she's done. We know she swam 6 laps, and I know that each lap is a quarter mile, 0.25. And then I know she ran the trail twice, and the trail is 3.3 miles long. And then I know she biked the trail 5 times, and again, that's also the same trail, 3.3 miles long. So that's the setup. And some of you might be seeing already, well, couldn't I have just added 2 plus 5 and gotten 7 times 3.3? And absolutely yes, since it's the same trail. Now they ask us to use order of operations to calculate this. Order of operations says that we multiply before adding. So I would do 6 times 0.25. And again, you're welcome to do that in a calculator. It becomes 1.5. 2 times 3.3 is 6.6. And 5 times 3.3 is 16.5. When I add those all together, I get 24.6. So on her first day, she completed 24.6 miles. Number 11 asks us how many more miles does she need to cover. Remember, we circled that 50 up in the problem. She wants a total of 50, so I have to take that 50 and subtract the 24.6 that she's already done. I'll go ahead and do that in the calculator just because it's good practice. 50 minus 24.6. She has 25.4 miles that she needs to go. Then the very last one has us switching gears again, and we're talking about calories and nutrition in a McDonald's meal. The website tells us that a regular hamburger is 250 calories, a small Dr. Pepper has 140 calories, and a small order of fries has 220 calories. We want to write an expression that shows the number of calories in a dinner consisting of 3 hamburgers, a small fry, and 2 small Dr. Peppers. So we're having 3 hamburgers times, we know those are 250 calories each, plus she's only having 1 small fry, so we'll add 220 to that, plus 2 Dr. Peppers, and those are both 140 each. You can do each one individually like we did in number 10. You could also just type this whole thing into your calculator because your calculator does know order of operations. So I could type in 3 times 250 plus the fries, 220. So the touch screen on the calculator is sometimes a little bit difficult. And then 2 times the 140 calories for the Dr. Pepper. And hit enter. And that tells us that that meal would be 1,250 calories. So your calculator speaks order of operations. It will do things correctly. Most of the cell phone ones do now too. It used to be the case they didn't, but most of them do order of operations correctly. So you'll get more experience using the calculator and working with simple and compound interest when you do the group part of this section. Thank you, and I hope you have a wonderful day.